Hello and Jai Hind everyone. Okay, so today we are going to start the solution of ND1 2026 mathematics paper. Okay, so as there were total 120 questions, so we will start it part wise. Today we are going to cover the calculus questions. If I talk about ND1 2026, total of 30 questions are from calculus and 35 were from algebra. So as of now, we are only going to cover some questions of calculus. Further in other videos, we will cover up the 2D, 3D, algebra and other portions as well. But as of now, let's get started. So question 71, it says that if fx is a differentiable function at x equal to a, then consider the following statement. Statement 1 is fx is continuous at x equal to a. Limit extending to a, fx is equal to f of a, and we have to tell that which of the statement given above is or are correct. So fx is a continuous function. What is given? Fx is a differentiable function. If a function is differentiable, the first condition for a function to be differentiable is the function have to be continuous. So if it is given that function is differentiable, it is a must that the function will be continuous. So the statement 1 is totally true. Statement 2. Limit x tending to a fx is equal to f of a. See, we can derive this statement 2 from the statement 1 as well. If a function is continuous, it means left hand limit will be equal to right hand limit that will be equal to f of t. Yes. So this left hand limit is nothing but limit x tending to a minus f of x is equal to limit x tending to a plus f of x is equal to f of a. A is because we are calculating the continuity at x equal to a. We are not calculating, it is already given fx is continuous. So we can simply write it like left hand limit equal to right hand limit equal to f of a. Now this whole, if we combine this whole, but this is our limit only. So if right hand limit, left hand limit is equal, it means limit will be defined. So limit x tending to a, f of x will be equal to f of a. So from statement 2, we can also confirm that statement from 1, we can also confirm that statement 2 is also correct. So in question 71, both statement 1 and 2 are correct. So C will be our answer. Now let's move to question number 72. What is limit extending to a x to the power n square minus 1 divided by x to the power n plus 1 minus 1 equal to? We have to find out the value of this limit where n is greater than 1 is a natural number. Okay, so whenever the limit question comes, what we simply do, first of all, putting the limit directly. If x limiting to 1, what we do, simply put x equal to 1. So when you put 1, x equal to 1, this will become 1 to the power n square minus 1 divided by 1, then 1 to the power n plus 1 minus 1. Now see, n to the power anything. Sorry, 1 to the power anything is 1. 1 minus 1 divided by 1 minus 1. So this is 0 by 0. I know that this is not defined, but 0 by 0 is an indication that here we will use the L hospital, or we also pronounce it L hospital rule. So here, see, you can also just write it down that whenever while doing the limit question, you find 0 by 0 form, it means we have to use the L hospital rule. L hospital rule. Okay. Now let's implement the rule. The rule say that we simply have to do the derivative of numerator divided by derivative of denominator. So derivative of x to the power n square minus 1. So that will be n square minus 1 into my x to the power n square minus 1 minus 1. Minus derivative of 1 is 0. So no need to write it. Further, in denominator x to the power n plus 1. So its derivative will be power will come in front n plus 1 into x to the power minus 1. So power was n plus 1 minus 1. So this will be the derivative. Now plus 1 will cancel out this minus 1. So our limit question become limit x tending to a, x tending to 1, n square minus 1, x to the power n square minus 2 divided by n plus 1 into x to the power n. Now simply you can put simply you can put the value of limit, that is x tending to 1. So this is n square minus 1 into 1 to the power n square minus 2. So 1 to the power anything is 1. So no into me 1, that will be n square minus 1 will be. In denominator this will be n plus 1. Now n square minus 1 is equal to n minus 1 into n plus 1. In denominator it is n plus 1. So n plus 1 will cancel out n plus 1. Our answer will be n minus 1. So C is the correct answer. I hope you know the basics. Okay, now moving ahead to question 73. What is limit extending to 0? Again, a question from 0 by 0 form. So if you see, even from a single concept, from a single rule, L hospital rule, we got two questions. That's great. So let's solve this question. Limit x tending to 0, 10 to the power sin x minus 1 divided by 10x. One way to solve this question is simply you can do the derivative of numerator and denominator. But there's another way. We can also write this tan x as sin x divided by cos x. Because from this way, I will be able to deliver some another concepts as well. It is 10 to the power sin x minus 1 divided by 10x is nothing but sin x divided by cos x. So cos x will come in numerator. See, if it is like limit extending to something fx into gx, so we can separate this limit. One time this limit will be on this function and another this limit will also get separated for cos x. So this whole first, let me write it, limit x tending to 0. We can also write it like 10 to the power sin x minus 1 divided by sin x into limit x tending to 0 cos x. As you know, when you put x equal to 0, this is cos 0 and cos 0 is 1. So this whole is equal to 1. Now what will be the value of this one? Again, here if you put x equal to 0, then 10 to the power sine 0, that is 0. 10 to the power 0, it means anything like any positive numbers or even any negative numbers power 0, it means 1. So 1 minus 1 divided by 0. 0 by 0, again we have to use the L hospital rule. And if you studied the L hospital rule properly, then there's a one limit extending to, let me write it, 10 to the power, not 10, but let's keep it a to the power x minus 1 divided by x. And it can be limit extending to a. See, if the question is in this form and if it is satisfying the condition that numerator while putting the limit, it becomes 0 by 0. So its answer will be log a. And if you see this pattern, this is exactly similar to what I have written here. So its answer will be log 10. No issue. If you cannot correlate this result, you can do the L hospital rule. You can put the uh, you can first write the derivative of numerator, then derivative of denominator, no issues. But if you know the result, directly write log 10. Log 10 into 1 will be log 10. Let's check. See, ln 10. When the base of log is e, you can also write it ln 10. So, for 73, answer is C. Let's move ahead for question 74. What is derivative of this with respect to x? See, where x is less than 0. This is very much important. Where x is less than 0. When x is less than 0, our this function x divided by mod x will become x divided by minus x, because when x is negative we will open this modulus sign with a negative sign, so x will cancel out x and this will become minus 1. So y equal to minus 1. We have to do the derivative with respect to x, so for y it will be dy by dx, and for minus 1 is a constant, so for a constant derivative is 0. 0, option B. Let me clear it. Yeah. So for question 74, answer is B, 0. Let's move ahead. Question 75. Consider the following statement in respect of the function fx equal to x in the interval minus 1 to 1. The function attains maximum value, the function attains minimum value. So the question is from application of derivative, where we have to find out the maximum and minimum values. So, starting from the concept, when you have to find out the maximum and minimum value, first you have to do the derivative. So, for some time, let's consider fx is equal to y, so y equal to x. Now do the derivative of this y. This will become dy by dx equal to, for derivative of x is 1. In the next step, what we used to do is, we used to put this dy by dx equal to 0. In the next step of finding a maximum and minimum value, we used to do that dy by dx is equal to 0. And by putting dy by dx is equal to 0, we have to find out the critical values at which our function will attain the maximum or the minimum value. But in this question, if you see, this dy by dx is 1. So when you put this dy by dx equal to 0, it means 1 equal to 0. First of all, it is not true. 1 is not equal to 0. So here we cannot find out any critical values. But no need to worry. If no critical values, no maxima and minima will be there. Between minus 1 to 1. If we are not able to calculate the critical values, how we can find out the maxima and minima? One way to understand this question, the function is saying the function attain maximum value, the function will attain minimum value. Two options are there. So this function will neither attain the maxima nor it will attain the minima, because there are no critical values are there. So one way to understand this question was this, from the traditional way, or we can say from the rules, how we studied it. Another way is from graph. If you see the graph of y equal to x, the graph is something like this. The graph of y equal to x, graph of y equal to x is like this, y equal to x. So here if you see, this graph is going till infinity and minus infinity in both of the side, minus 1 to 1. Here it will be 1, here it will be minus 1. When you start to study about maxima and minima, you have studied that the maxima and minima attain, a function attain its maximum value either at the turns, when the graph get turned, or either at the ends. But in y equal to x, there's a no turn you see. It's a straight line. I know it is not looking like a straight line, but just imagine it's a straight line. Yeah, this is a straight line. So there will be no maximum and no minimum value of y equal to x. Now, for our question number 75, D will be the answer. Now, question 76. Let me first clear. Question 76. Question 76. Okay. Y to the power 1 by 4. See, y square root 4. It means y to the power 1 by 4 equal to x plus root x square plus 4. Then what is the value of this whole? We have to find out the value of root x square plus 4 into dy by dx. Into dy by dx, it means the first step that we will think of in our mind is calculating the dy by dx. So let's calculate. Now y to the power 1 by 4. So first the derivative of power. This will become 1 by 4 into y to the power 1 by 4 minus 1 into me y's derivative will be y dash. X derivative 1 plus root x square plus 4 derivative. If you remember a very famous term PBA, power base angle. That's a very famous term or I can say short trick in derivative. In derivative, first we do the derivative of power, thereafter base, and if any angle is there, then we do the derivative of angle. So first I am doing the derivative of this root. So root में function, its derivative is 1 by 2 root में function. Function is x square plus 4. Thereafter, this main function is x square plus 4. So for x square, derivative is 2x, and for 4, it will be 0. 2 will cancel out this 2. 1 by 4. See, y to the power 1 by 4 minus 1 will be minus y to the power minus 3 by 4. Y to the power minus 3 by 4 into me y dash, it means dy by dx equal to 1 plus x divided by root x square plus 4. Now y to the power, this is 4. This is 4. 1 by 4. Y to the power minus 3 by 4 can be written as y to the power 3 by 4 in denominator into my y dash, it means dy by dx equal to, take this will become root x square plus 4 plus x divided by this whole root x square plus 4. Now if you see the question again, this x plus root x square plus 4, the same is equal to y to the power 1 by 4. 1 by 4 into 1 divided by y to the power 3 by 4 y dash, this whole is equal to y to the power 1 by 4 divided by root x square plus 4. Now if you multiply this y to the power 3 by 4 with y to the power 1 by 4, this whole will become y. So dy by dx into 1 by 4 is equal to y divided by x square plus 4. Now if you see, we have to find out root x square plus 4 into dy by dx. What if we take this root x square plus 4 in this left hand side? So this whole will become root x square plus 4 into dy by dx, and take this 4 in right hand side. So this will become 4y. So this will be the answer that we have to calculate, the value of root x square plus 4 into dy by dx, that is 4y. So correct option is option D. Now moving ahead to our question 77. What is the length of longest interval in which the function is decreasing? Function is decreasing. Okay, so for a decreasing function, we have to find out the derivative, and thereafter we have to put it less than 0. So first do the derivative of this function. 2 into for cos 2x, it will be 2 into cos x, it is 2 into 2. And for cos x, the derivative is minus sin x. The derivative of 1 is 0. So no need to write it. The derivative have to be negative, have to be less than 0 for a decreasing function. Now 2 into 2 will be 4 cos x minus can be taken outside. This will be sin x less than 0. Now minus 2 into 2 cos x sin x. This can be written as sin 2x less than 0. Now this minus 2, take this minus 2 in right hand side. This will become sin 2x. When you divide 0 with minus 2, it will be 0. But if you are taking minus 2 in right hand side, this sign of the inequality will become changed. This will become greater than 0. Sin 2x greater than 0. When, see, if you find the interval where the sine 2x is greater than 0, the interval in which sine 2x is positive greater than 0, in that interval our function will be decreasing. In that interval, this function will be decreasing. So let's find it out in which interval sine 2x is greater than 0. The best way for it will be the graphical method. So make the graph of sine x. Yeah, sine x. The graph of sine x and sine 2x is same. when we see it. But when it comes to the value of x, see, sine x is maximum at pi by 2 because sine pi by 2 is 1. But sine 2x is maximum at x equal to pi by 4. When you put x equal to pi by 4, this will become sine pi by 2. So that is 1. So in sine 2x, it is x pi by 4. It means this much from 0 to its highest value. Sine 2x is attaining its highest value from 0 to pi by 4. So this much, like this interval is pi by 4. This interval's length I can say is pi by 4. See, in which 0 to pi by 4, this here our sin x is increasing. From this to this, our sin x is decreasing, sin 2x is decreasing. Now, this interval is again increasing. So if you see the length, this is only at that much length and this is double of this. So this is pi by 4 and this is pi by 4. So this pi by 2 length, see I'm talking about length. This much is pi by 4 and this much is pi by 4. So pi by 2 will be the biggest length in which our sine 2x will be greater than 0. So pi by 2. And this is also the length or I can say the interval in which this function will be decreasing. So this is our pi by 2. See, the question was I can say quite easy, but maybe we get confused when we talk about the graphical method. Because the first way that I can think after sine 2x is greater than 0, and even it is not asking about interval, it is asking about length of interval. And even it is not x, it is sine 2x. So just you can also back the video and can, if you have any doubt, you can clear it out. But yeah, this is pi by 4, the answer is pi by 2. Still, if you have any doubt, you can let me know. Okay, as of now, we can move ahead. Question 78. A and B are acute angles. Acute angle, it means angle that is less than 90, such that 2a plus 2b is pi. So a plus b will be pi by 2. Okay, then what is the maximum value of sine A and into sine B? Maximum value of sine into sine B. Let's consider this sine A into sine B equal to y. First of all, what we will do, we will convert this b into a. Can we convert? Yes, we can convert. B is equal to pi by 2 minus a. So this is our sine A. Sine pi by 2, it means sine will become cos. Pi by 2 minus a, first interval, sine will be positive, so cos a. Sine A into cos a. This is just nothing but y. We are just changing the, converting b into a. Now again the another operation that can be done is multiply this expression with 2 and divide this expression with 2. Still it is sin A into sin B, but what will be the advantage? The advantage is 2 into sin A cos A will be sin 2A. Okay, now our y is 1 by 2 sin 2A. We have to find out the maximum value of this. So how we can find out? By doing derivative. Again use the concept of maxima minima and do the derivative. 1 by 2 into derivative of sin 2A cos 2A, and 2A's derivative is 2. First we will put it equal to 0. Cos 2A is 0. So see, cos A, if it is like cos x is 0, x will be pi by 2, but it is 2a. So, okay, let me make it clear. If it is cos A, then our A will be pi by 2, but it is 2a. So 2a will be, see, how, let me write it again. First clear it whole. Okay, so if cos 2a is equal to 0, then take cos in right hand side 2a, cos inverse 0. So cos becomes 0 at pi by 2. Then a will be pi by 4. A will be pi by 4. So at pi by 4, our function will attain this y will attain the maximum value. We have to tell the maximum value. So 1 by 2 sine 2 into a is pi by 4. So sine pi by 2 that is 1. So final answer is 1 by 2 a. For 78 the answer is A. Now moving to 70 question number 79. Course is given. We have to basically solve the differential equation, no issues. First of all, find the dy by dx. Dy by dx will be cos inverse p. Now take this x in right hand side, integrate in both of the side, y equal to cos inverse p is a constant, cos inverse p into 1 is x plus c. We also have to calculate the value of c. So first put x equal to 0, this whole will be x, y is q, so q equal to c. Value of q is c. So our differential equation become y equal to cos inverse p into x plus q. See, it is the basic concept of differential equation. Y minus q divided by x equal to cos inverse p. When you take cos inverse in this side, this will become cos y minus q divided by x equal to p. So option A is the right answer. Now moving to question 80. See, again, this is also a famous pattern. Whenever such type of questions are given where x 1 minus x is given, so what we have to do is, but we will put it equation 1 and we will create the equation 2. How? By putting x equal to 1 minus x. By putting x equal to 1 minus x. So in second equation, this will become 2 f of 1 minus x. When we put here f, put x equal to 1 minus x. 1 minus x. So this 1 will cancel out this one, minus minus plus. So this will become fx equal to 1 minus x. So what we have done is simply put x equal to 1 minus x. Again, I'm repeating, put x as 1 minus x. This will be our equation 2. Now, multiply the equation 1 with 2. What will be the advantage in that condition? This will become 4fx and 2f of 1 minus x will become 2f of 1 minus x equal to 2x. Now subtract these equations. This will become minus 3fx equal to 1 minus x and this is 2x. So this will be 1 minus 3x. Take minus 3 in this side. So this will become 3x minus 1 divided by 3. So this is x minus 1 by 3. X minus 1 by 3, option B is the right answer. The main thing to understand in this question was replacing x with 1 by x. See, the question can be asked like this as well. 2x f of 1 minus x is equal to something. So in 3 minus x, let's take it 3 minus x. In that case, the another equation have to be created by replacing x with 3 minus x. Okay, so we have covered the solution from 71 to 80. We will continue the another questions of calculus in our next part of this video. Till then, just keep practicing, keep learning. Thank you.